All right, so this is part one of the final exam review for Math 136, day one. So we're going to do the first 9 problems on this video, and then we will do the next 9, and then the next 9, and the next 9. So there's going to be a 4-part video series. So for the first example, it says simplify. Answer only with positive exponents. So notice that the operation connecting these two parentheses is multiplication. So we should be multiplying things together. So 5 times 4 would be 20. And x squared times x to the negative fifth. Remember, you would add exponents because you're multiplying the same base. So that would be x to the 2 minus 5, so that'd be negative 3. And then y times y, and it's negative 3 plus 4, so y to the first. Our answer can only have positive exponents, so we need to move the x to the negative 3 to the bottom. So 20y, and then over x to the third. Looking at number 2, it says factor the polynomial. We have 8x cubed and negative 125. Those are both perfect cubes. When we factor perfect cubes, you get a binomial times a trinomial. And remember, we had a little saying to help us remember our signs. SOAP. Same as the original, opposite to the original, and always positive. The cubed root of 8 is 2. The cubed root of x cubed is just x. The cubed root of 125 would be 5. In your binomial, you just use your 2 cubed roots with that symbol, so 2x minus 5. In the trinomial, there are 3 spots. We do all pairings of 2x and 5. In the first spot, you do 2x times itself. In the second spot, you do 2x times 5. And in the final spot, you do 5 times itself. So this would make 4x squared plus 10x plus 25. So that is the final answer. Number 3 is a little bit of a longer problem. This is that large factoring problem that we learned. So we're going to have to clean this up a little bit. And what I mean by that is on this part right here, there's a plus sign right here, so there's actually 2 pieces. There's all of these monomials that can be multiplied together. We can't really multiply anything else together because they have powers on them. So negative 3 times 2 would be negative 6. Bring down everything else from that first part. So 3x plus 1 to the 6th. And 2x minus 5 to the negative 4. 6 times 3, because there's my plus sign, would be 18. And then bring everything else down. 3x plus 1 to the 5th. And 2x minus 5 to the negative 3. You want to then find a GCF for all of these 2 pieces right here. So I'm going to pull out a 6, and I could pull out the negative I want, but I don't think I actually want to because I already know how the answer is going to work out. But if you pull out the negative, you should still be fine at the end because I think on the answer key we gave you 2 versions of the same answer. The 3x plus 1s, they have 5 of them in common, so we'll pull that out. When you're dealing with a negative exponent, you always want to pull out the smaller of the numbers. So that would be the negative 4, because remember, negative 4 is actually smaller than negative 3. What that will leave us with is a bracket of leftovers. So you just go piece by piece and ask what happens if I pull this out. So negative 6 divided by 6 would be negative 1. I would have a 3x plus 1 left over because I had 6 of them and I only pulled out 5. I pulled out all negative 4 of the 2x minus 5s. 18 divided by 6 would be positive 3. I pulled out all of the 3x plus 1s to the 5th. And I had negative 3 here, but I pulled out negative 4. What that means is I actually have a positive 1 left over inside. The reason that works is if you were to multiply or distribute back through, negative 4 plus 1 would give you negative 3. So these are both to the first power. So we need to clean up the inside here. So this would be negative 3x minus 1 plus 6x minus 15. So I have 6 and then 3x plus 1 to the 5th. I'm going to go ahead and write this part because I know I'm going to have to move this negative exponent down. This would be a 3x and a minus 16. And then because this has the negative exponent, this binomial will go to the bottom. And that is my final answer. Number 4 is a division problem. So one of the ways we can try to do division is to try to multiply by the reciprocal. So flip the bottom fraction. Once we do that, we can factor the top of that second fraction. This is times. This would be x plus 4 and x minus 4. That's 4x. The x minus 4s are going to cancel. And the 2 and the 4 are both in a monomial, so they can reduce. So this would be a 1, and this would be a 2 and an x. So on the bottom, I have a 2x, and on top, I have an x plus 4 times 1, which would still be x plus 4. All right, for number 5, we need to try to solve this equation. If there's fractions involved, you want to try to clear out the fractions. Factor all of your denominators first. And also realize that you do have domain errors here. So x cannot equal negative 1/2 for that piece, and x cannot equal positive 1/2. So just make sure your answer at the end is neither one of those numbers. So our rule for this was that we multiplied by the LCD. The LCD is going to be both parts. So if we multiply everything by that, just write it in. So we've got all of our factors multiplied across, and we're going to look for cancels. So we have the 2x plus 1s are going to cancel in the first fraction. The 2x minus 1s are going to cancel in the second fraction, and in the last fraction, the whole denominator will cancel out. So what we're left with is there's a numerator, so that's a 4, and a 2x minus 1. I know that was kind of hard to see. And then there's a negative in between the first two fractions. And then there's a 3 and a 2x plus 1 and equal sign, and then we just have our numerator of 2x plus 7. Distribute, we get 8x minus 4, and then negative 6x minus 3. Bring down everything else. Combining like terms, we'll get 2x minus 7 equals negative 2x plus 7. Be careful when you're moving things over here. A lot of people will cancel things out, but they don't actually cancel. This would be 2x equals negative 2x plus 14. Add 2x over, so nothing actually cancels out. We still have our x's, in other words. So this is 4x equals 14. Divide by 4. Reduce that down, x equals 7 over 2. And that is not negative 1/2 or 1/2, so the answer is okay. For number 6, we have one of our word problems. It says if it takes a girl 45 minutes to deliver the papers on her route. However, if her brother helps, it will only take 20 minutes. How long would it take her brother to deliver the papers by himself? So the girl by herself, she gets 1/45 of her job done per minute, because we're assuming she works at the consistent rate. Otherwise, this is a much harder problem that we can't do with just algebra. And then we know that if they work together, so I always call that the combo, it'll be only 1/20 of the job per minute. What we want to know is what happens if the boy works by himself, so that's our 1 over x part of the job done per minute. So we add the two solo parts together, so the girl plus the boy equals the combo. You could get an LCD here if you wanted, so things that 45 and 20 go into, if you don't know, you make a list. I would start with 45 since it's bigger, so 45, then 90, then 135, so I'm just adding 45 each time, and then 180. 20 will go into 180, that's the first thing. So we'd have to times 20 by 9, and we have to times 45 by 4 to get those two numbers to both be 180. So that's if you want to get a common denominator and then clear your fractions. I'm just going to multiply everything by 180 and x, because if I multiply everything in my equation by that, all of my denominators will cancel out because they're all divisible by either 180 or x. or they divide into, I should say. I said that backwards. So 45 goes into 180, we said 4 times, so this would be a 4 and an x times a 1, so that would be 4x. There, my x was missing there. So x and x would cancel out, and this is just 180 times 1, so that would be 180. And here 20 goes into 180, we said 9 times, so that would be equal to 9x. Subtract over the 4x, and this is 5x, and then divide by 5. And I believe that comes out to 36 minutes, but let's double check. So 180 divided by 5 is 36 minutes. So if the boy worked by himself, it would take him 36 minutes to finish the paper route. The next one is also a word problem. It's the one about admission tickets to a motion picture. 600 people attended the premiere of a motion picture. Adult tickets cost $5 each, and children were admitted for $2 each. If the box office receipts totaled 2,400, how many children attended? So we're going to let X be the number of children, since that's what we care about, and I'll be able to solve for that right away. So 600 is the total number of people that were at the event. So if you already know that there's X amount of children, the rest of the group, so 600 minus the children, would be the adults. Then we just multiply each of these informational pieces, number of children, number of adults, by the ticket price. So $5 for every adult, so that was our 600 minus X, plus $2 for every child, equals total ticket price of 2,400. And yes, you can still do this one by a system if you're more comfortable with that. I'm just doing this by the method that the book we had went through, which was using only one variable. So this would be, subtract that over, that would be negative 600. This would be negative 3x. Divide by negative 3, and it looks like we're getting 200 children. Now, they didn't ask us for the number of adults, but if they did, it would be 600 minus 200, so that would be 400 adults. For number 8, we're trying to solve this equation using the quadratic formula. Please do not ever plug fractions into the quadratic formula if you don't have to. I would multiply everything here by 40, since 8 and 5 both go into 40. That would be our LCD. If we multiply everything by 40, then we can get rid of all these fractions, because fractions inside the quadratic formula are not your favorite cup of tea. So 40 times 1 over 8 x squared plus 40 times 4 over 5 x minus 40 times 1 equals 40 times 0. 8 goes into 40 5 times, so now I have 5x squared. 5 goes into 40 8 times. 8 times 4x would be 32x. Then I would have negative 40 times, because that's times 1, and then this would still be 0. So my A is 5, my B is 32, and my C is negative 40. So we do our quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's work out the inside of that radical. So 32 squared is 1,024. And then we have to do negative 4 times 5 times negative 40. So negative 4 times 5 times negative 40 is positive 800 all over 2 times 5, which is 10. We need to add those two numbers inside that radical together, which is not too bad. That's 1824. And we need to check to see if 1824 has any perfect squares that go into it. So let's divide it by 4. That would be 456. Could there be something bigger? 1824 divided by 16 possibly. And that would be 114. So that looks like a better option. So 16 times 114 equals 1824. So the square root of 16 is 4. And then 14 is not got any perfect squares that go into it. And then the only thing about this that's a little bit questionable is that all the numbers in front of everything are all divisible by 2. So we should really reduce that down. So this would be, if we divide everything by 2, that's an outside number. Remember, it doesn't affect the radical. This would be negative 16 plus or minus 2 on the square root of 114 all over 5. So that would be my reduced answer for this one. And then number 9 is a complex rational equation, or expression, excuse me, and we need to rationalize it so that it is in A plus BI format. When you rationalize, you use something called the conjugate. You multiply the bottom by the exact same binomial, but you change the sign in the middle. Whatever you do to the bottom, you have to do to the top. So on top, we are foiling out this, negative 4 plus 6i times 2 minus 7i. On the bottom, we are foiling out the conjugates. You have to do both, though. So you should still have numerators and denominators. So negative 4 times 2 is negative 8. Negative 4 times negative 7i would be positive 28i. 6i times 2 would be 12i. 6i times negative 7i would be negative 42i squared. Remember that an I squared is a negative 1, so this guy can actually be marked out, and it is positive 42. On the bottom, 2 times 2 is 4. Then we get a negative 14i and a positive 14i, which are going to cancel each other out. And then 7i times negative 7i is negative 49i squared. Again, the I squared is a negative 1. So this negative 49 becomes positive 49. So we combine like terms on top. 42 minus 8 would be 36. No, let me double check myself. It's way too late. No, it's 34. I didn't think that looked right. So 34. And then 28 plus 12i would be 40i. And then this is all over 4 plus 49, which is 53. Now you can't leave your answer like that because it's not split into 2 separate parts, a real part and an imaginary part. So you final part is to split that into 2 fractions and make sure each fraction is reduced, which in this scenario they are. All right, so that's the end of the part 1 video.